Greetings to every one of you. So in this video we are going to discuss minimax procedure with alpha beta pruning. It is an advanced version of minimax procedure. It avoids useless branches in the decision tree. The maximum player updates the value of alpha as higher. The minimum player updates the value of beta as lower. So already we discussed in minimax procedure, mainly to reduce the time complexity, we introduce the two important parameters, that is one is alpha and this is beta. Unwanted searching can be reduced with the help of the parameters alpha and beta. So the main condition we have to check if this alpha value it is greater than beta, we can skip that particular path of search. Let us see how this kind of is done with the help of this example. So here a game tree is given here, contain the terminal nodes, 14 terminal nodes are there, and the first node, that is a root node, which represent the maximum player, that is alpha, and the second level, that is minimum player, that is beta, and again the level that is 2, this is level 0, level 1, the level 2, that is maximum player with alpha, and level 4, that is minimum player with beta, and these are the terminal nodes. So here we are following the depth first search. So we will start the search only from the lower left node. So that is T1. So the value of T1 is 6, and that will be backup to the parent, that is D1. Now the value of that is D1, that will be compared with this T2. Here it is a minimum player, that is beta. So it will consider only the minimum value among these two. So this is 6, and now the value 6 will be compared with the value of T2, that is 7. 6 is lesser than 7, so 6 will be retained as it is. This value will be backup to its parent, that is C1. So C1 takes the value, that is 6. Now from C1 again we have to do our DFS, that is depth first search. So reaching the node, that is T3. The value of T3 it is 8. So 8 will be backup to the parent, that is D2. And now the value of this D2, if you compare with its parent, that is C1. So 6, that is the alpha value, it is not greater than 8. So we can proceed the search with the next element, next node. So the value of T4 it is 5. If you take the value, that is 5. If you compare these two, we have to take the minimum one. So what will happen, this 8 will be cancelled, and the value of D2 will be updated into 5. Now compare this value, that is alpha with beta. So value of this alpha it is 6 and the beta is 5. So 6 is greater than 5. So what we have to do, we have to avoid this search. You need not perform this search at all, because already what is that, the value of alpha it is greater than the beta value. You need not perform the search, skip the search. Now the value that is 6 will be backup to the parent, that is B1. Now again from B1 we have to perform the searching. So reaching to the node T6, the value of node T6 it is 4. So 4 will be backup to, that is D3, and again the same value will be backup to its parent, that is C2. So now we have the value, that is 6 and 4. From this we have to select the minimum value. So it is the minimum player, that is beta. So beta needs only the minimum value. So what will happen here, the comparatively 4 is the minimum value. So the value of B1 it will be updated with value 4. So 6 will be cancelled. And again this 4, it is back up to the parent, that is the root node. So now the root node takes value, that is 4. Now again we perform the search starting from the root and reaching the corresponding the terminal node, that is T7, and the value of T7, it is 7. So it is back up to that its parent, that is D4, and from D4 to that is C3, and here from C3 to we have to perform again this check the terminal node, the corresponding terminal node, that is T8, that is also 7. So this D5, it is 7. Now if you compare this node, that is the value of D5 with that is C3, so value of C3 it is 7 and D5 it is also 7. So now alpha is equal to beta. So in our condition I said alpha it is greater than or equal to beta, skip the search. So this being the case, we have to skip this search. So already we skipped this search, and again this path of search, it is also skipped. Now the value, that is 7, and 7 will be, that is back up to this parent, that is B2. So now the next value, it is T10. The next value is T10. The value, that is 8, it is back up to the parent, that is D6, and again same value will be, that is back up to the parent, that is C4. And now if you compare these two, there is 7 and 8. So the minimum value will be, that is considered 7 is the minimum. So that value 7 will be, that is retained here. So again this value, that is back up to the parent, that is A1. So here once it comes here, if you compare these two, this is 4 and this is 7. If you compare these two, we need the maximum value. So automatically the 4 will be, that is cancelled. A1 will be updated as 7. Okay. So this part of search is over. One part of search is over. Now we come to the next part. So from B3 we will reach the terminal node, that is T11. The value of T11 is 6. So 6, it is updated here. So again the same value, it is updated to its parent, that is C5. Then again same value, it is updated here, that is B3 is also 6. So now compare this value with before proceeding the search, compare this value with the root node, that is 7. 7, it is greater than 6. So that is alpha, it is greater than beta. So now we can cut this search. We can stop this search. We need not proceed this search at all. So this part of the tree, it is totally, that is skipped. Okay. So with the help of this alpha beta pruning, so alpha beta cutoff, it is also called cutoff, we are able to, that is stop the searches. There is one search here, another search here. So another one particular part of search, it is avoided. So because due to this particular reason, we can reduce the time complexity. So this is the advantage of using the alpha beta pruning. So the final result of this root node, that is A1 is equal to 7. So now we can find out the path of this 7. So here there is A1 to B2, then B2 to, that is C3, and C3 to D2, I mean D4, from D4 to T7. So this is one particular path. So similarly we have another path is A1, B2, C2, then it is D5, then T8. So this is the optimal path. So in this video we discussed what is minimax procedure, and what is alpha and what is beta, what is the condition for performing this alpha beta pruning, and I explained with the help of this example. I hope you understood the concept. Thank you. Keep watching.